Great, here's today's work. This is called a solubility chart, sometimes called solubility curves because rather than straight lines, they usually look a little bit more like this. But we're going to keep it easy, do these ones today. I'm going to work you through. We're going to answer this practice set, and then in classroom, I'm going to post the practice set for you to work on. So we're going to be coming back and referencing this chart frequently, but for now, let's go to the questions. So, number one, how many grams of both substances X and Y can dissolve in 10 milliliters of water at 70 degrees Celsius? So a couple things to look at here. First off, we need two numbers. We need question substance X and substance Y. Our answer needs to be in grams. The amount of water we're using is 10 milliliters. And then the temperature is 70 degrees. So we're going to take this one bit at a time. First, we're going to come up here to substance X. First, I'll be using orange for substance X. So let's make that line orange so it's nice and clear. Yeah, that's good. Okay. First, we have 10 milliliters of water. Now, luckily, this y-axis tells us 10 milliliters of water. So we don't need to do any adjustments because this line already tells us in 10 milliliters of water. Next, we have a temperature, 70 degrees Celsius. There's our x-axis. Degrees Celsius, we're looking for 70. Now, what we do is we look at this line and where it intersects this temperature line. So we're going to start at 70. We're going to go all the way up. Just follow the line. And where they intersect is right there. Now the question's asking how many grams of substance X can dissolve in 10 milliliters of water at 70 degrees Celsius. This point where it intersects, that's what tells us how many grams of solute can dissolve. So we're going to follow this point sideways, and we end up right about here. Now that's cool, but how many grams is that? If we look at our scale, 0 starts here, and then that's 2, that's 4, that's 6, which means the lines in between are our odd numbers, 1, 3, 5, 7, etc. So we have 20 here, and this one's 21. So we're between 20 and 21. It's a little closer to 21, so let's call it approximately 20.7, and then our unit was grams. Grams. Now we're going to do the same thing, but with substance Y. So let's make that line a little bigger. Now let's clean up some of these excess strokes that we don't need anymore. There we go. Okay, so we're still using 70 degrees Celsius, 10 milliliters of water, but this time we're going to substance Y. So there's the intersection. We're going to follow it over this way. Boom. 8 grams. .0 grams. Now, before we move on, we're going to have a little bit of info to add to this. So, what's going to happen if I'm not asking you always where does it intersect? So let's use substance X. Let's say at 50 degrees Celsius, I have 10 grams. So if I dissolve 10 grams of solute in 10 milliliters of water at 50 degrees Celsius, my line is right here. Not my line, my dot, my saturation point. What that tells me is that because it's underneath this solubility curve, this is an unsaturated solution. If it falls perfectly on the line, let's say right here, that means at this temperature, in this amount of solvent, it is saturated. And if it falls above the line, let's say 20 degrees Celsius, 10 milliliters of water, I have 15 grams of solute. This is supersaturated. Now, if you remember your vocabulary words, saturated means there's the perfect amount of solute in your solvent. Unsaturated means there's not enough, you can fit more in it. And supersaturated means there's too much. There's extra. So, if it's above this line, supersaturated. If it's right on the line, it's saturated. And if it's underneath the line, it's unsaturated. Now those numbers can shift depending on the temperature, how much solvent you have. There we go. What substance you're actually looking at. For instance, substance Y above the line is all of this. So that would be your supersaturation point. Whereas your unsaturated would be everything down here. You have a couple questions where you'll practice that. But number 2. At what temperature do both substances X and Y have identical saturation points? Now, your saturation point is the point right on the line. That's where you have exactly the right amount of solute in your solvent. Now, we're looking for the point where these two lines intersect, where they have the exact same number. That's right there. And the question's asking us the temperature. That's the x-axis, so we have to come down to here. Now, just like the y-axis, we need to figure out what our scale is. We have 0, 10, 20, 30, which means the numbers in between are the odds, multiples of 5. So it's greater than 10, less than 15. Let's call it approximately 12.5. Are we done? No, no, no. No naked numbers. It's asking for a temperature. So temperature on our graph is in degrees Celsius. Now, we started off really slow. It took us this long to only do 2, but for the most part, these are much faster. Next question, at what minimal temperature must water be at in order to dissolve 23 grams of substance X in 10 milliliters of water? Now, instead of temperature, this time we're starting off with grams. We're looking for 23 grams. So, 23 grams. This is our starting point. And the question's asking us, what temperature must it be to dissolve? So we're going to come this way. Boop. There's our point. We're going to follow it down to the x-axis. And it's right about here. So we're going to call that approximately 72 degrees Celsius. Excellent. Number 4. If 9 grams of each solute is dissolved in 10 milliliters of water in separate containers at 70 degrees Celsius, describe each solution. Is it saturated, unsaturated, or supersaturated? So, we need to go to 70 degrees Celsius. Oops, first we need to clean up our graph. Got too much going on in there. There we go. So, 70 degrees Celsius. and we have 9 grams of solute. So 9 grams is right there. Now it wants us to describe it as saturated, unsaturated, or supersaturated. In reference to substance X in orange, this green dot is below the line, which means X is unsaturated. I don't feel like writing the whole thing. Substance Y, on the other hand, that dot is above the line, which means it is supersaturated. If either dot was perfectly on that solubility line, then it would be saturated. But if it's above, supersaturated, underneath, unsaturated. Let's clean it up. Okay, now in this next one, we have some vocabulary words. How much precipitate will be on the bottom of the container if a saturated solution of substance Y in 10 milliliters of water is cooled from 90 degrees to 40 degrees? So, at 90 degrees, substance, 90 degrees, we have a saturated solution. So our saturation point is right there, 10 grams. Now, that's at 90 degrees. If we cool it down to 40 degrees, now that 10 grams is still in the solution. We haven't taken it out, but now only 5 grams can dissolve. A precipitate is when you have a solution and the solid that forms at the bottom is the precipitate. So when it was saturated, it could hold 10 grams. When we cooled it down, now it can only hold 5 grams. So the difference between the two is how much is now out of solution. It can't dissolve anymore, so it falls to the bottom of the container. 10 minus 5 is 5. So how much would be as the precipitate? 5 grams. Now, starting at number 6, we're going to have an extra step. I'm not going to give you problems like this very often, but knowing how to do them is still good. Now, how much of substance X can dissolve in 50 milliliters of water at 65 degrees Celsius? Now our amount of water has changed. Everything up until now has been 10 milliliters because our graph is in 10 milliliters. But now we have 50 milliliters. To solve this, we're going to take how much water we have. In this case, it's 50 milliliters. And we're going to divide by how many milliliters our graph is in. Our graph is 10 milliliters. Now, when we divide, we get 5. So what that tells us is we're going to look at the saturation point at 10 milliliters, whatever that is, and then we're going to multiply times 5. Multiply. So we're going to pretend that this really says 10, and then we're just going to multiply that answer by 5. So we're going to go up to 65 degrees Celsius, 65 Celsius, and we're looking at substance X. So right about there. I would call that probably 18.5. And then what we were doing, let's write this down. It's 18.5 grams at 10 milliliters. So we're going to take that, and we're going to multiply by 5. And that's going to give us our answer, 18.5 times 5, 92.5 grams. Now I'm going to work through these final three a little bit faster. In this case, for number 7, we have 5 milliliters. So we're going to take 5 milliliters, divide by 10 milliliters. We're dividing by 10 because that's what our graph is in, 10 milliliters. Let's clean it up. There we go. So 30 degrees Celsius, substance Y. 30 degrees Celsius, substance Y holds 4 grams, but 5 divided by 10 is 0.5. So we're going to take 4 grams and multiply by 0.5, and that gives us a total of 2 grams. Great. Now, let's do number 8. Describe the solution which contains 27 grams of substance Y at 80 degrees Celsius in 30 milliliters of water. This time we have 30, so it's 30 divided by 10. We're going to multiply by 3. All we're doing is applying each concept that we've already learned. So 80 degrees Celsius, substance Y holds 9 grams, but it's 30 milliliters of water, so we're going to multiply by 3. 27 grams, but the question is asking us, is it saturated, unsaturated, or supersaturated? If 9 was perfectly on the line, that means it's saturated. That's 10 milliliters of water, so if we triple it, we can triple the solute, which is 27, which means 27 grams at 30 milliliters will also be perfectly on that line, on the solubility line, which means it is saturated. The question is not asking you how much can dissolve, it's asking you, is it saturated, supersaturated, or unsaturated? It is saturated. Okay, final one. How many grams of substance X would you need to dissolve in 15 milliliters of water to prepare a saturated solution at 10 degrees Celsius? 15 divided by 10 gives you 1.5. We're going to go up to 10 degrees Celsius. Substance X is about 1.5 grams. So we're going to take 1.5 grams, and we're going to multiply by 1.5. 1.5 times 1.5 gives us 2.25 grams. Done. Now, for your assignment, you're still going to use this same solubility chart, and the paper will look exactly like this, just different numbers. Other than that, exact same applications. So, yeah.